everyone! Analyzing graphs of quadratic function has been and will be a necessary skill not only in mathematics but in everyday living. Quadratic functions can be used to track to the position of any object that has been thrown, shot, or launched near the surface of the Earth. In this video, we will be focusing on analyzing graphs of quadratic functions. Thank you, Mr. Emilito Vigallegos, my principal, for allowing me to use his material during his teaching years in discussing this topic.
Yes, Miss MJ, you're welcome. You know that I will be more than happy to share with you all my materials.
Hi guys! I hope you're doing great today and already prepared for our lesson. So what you're going to do is sit back, relax, and enjoy watching this video while learning mathematics. At na! So let's see what we have here. So we have quadratic functions. Now in quadratic functions, we will learn from it its graph, its table of values, its domain, range, and even the behavior of its graph. Okay, now let us see what is the focus of our discussion this time. The focus of our discussion is to analyze the effects of changing the value of A in Y equals the product of A and the square of the difference of X and H plus K, where H is equal to 0 and K equals 0. Or simply, to analyze the effect of changing the value of A in the quadratic function Y equals AX squared. Now, let's look at some examples. Our first example, we have the quadratic function y equals x squared. So this is the corresponding table of values. If x equals 0, the value of the function is also 0. If x equals negative 1 and positive 1, the value of the function is the same, 1. If x is negative 2 and positive 2, the value of the function is also the same. Now we observe that the values of the function to the right of 0 and the values of the function to the left of 0 here are the same. So as we can see, there is a reflection of values. Now let's look at the graph. There are pairs of coordinates like like a mirror of each other. So let's look at the graph. So we have here the graph or the curve of the quadratic function is called a parabola. Now let's have another example. We have quadratic functions defined by y equals 2x squared, and its table of values we have if x equals to 0, the value of the function is also 0. If x is negative 1 and positive 1, the same value we have here, positive 2. If x is negative 2 and positive 2, the value of the function is the same, which is 8. Still, there is a reflection of values in our table function or table of function. So let's look at the graph. So that's the graph of y equals to x squared. Let's have another. We have a quadratic function defined by y equals 1/2 x squared. So its table of values, there is also a reflection of mirroring of values of the function. So in its graph, so these are the corresponding graphs of these three quadratic functions here. So let's have another set of quadratic functions. Or let's first look at some properties of this quadratic function. Now here, our a is equal to 2 or positive 2. Here we have a equals 1 or positive 1. Here our a is equal to 1/2 or positive 1/2. So let's have another set of quadratic function. Now this time we have y equals negative 1/2 x squared, and its table of values, we have here the corresponding values of x, or the values of x with the corresponding values of the function y. Still, we observe there is reflection of values of the function. Then let's look at the graph. And the second one, we have y equals negative x squared. We have here the table of values and the corresponding graph. And the third example, we have y equals negative 2x squared with its table of values and the corresponding graph. Now let us try to compare the two sets of the function. So here RA in the first set of functions are all positive. A equals positive 1, a equals 1/2. Let's look at the second set of example. Our a is equal to negative 1/2, a is equal to negative 1, and a is equal to negative 2. Now, what do you think is the effect of the values of a? What do you think is the effect when a is positive and when a is negative? Okay, correct. So, if the value of a quadratic function is positive, the parabola opens upward. If the value of a in the quadratic function is negative, the parabola opens downward. Now let's try to, here the value of a is positive 2, positive 1, positive 1/2. Which of these three values has the smaller value of a? Yes, 1/2 is smaller than 1 and 2. Now let's look at the graph. This is the graph of a equals 1/2, and this is the graph of the parabola of a equals 1, and this is the parabola of a equals 2. As we have seen, or as we can see, the parabola of a equals to 1/2 is smaller than the other two is wider. The parabola is wider when the value of a is smaller. As a becomes smaller, the parabola becomes wider. Now let's look at another, or the opposite. We have here 2 is bigger than the other two values of a. And now let's look at the graph. Its graph is narrower than the other two graphs or parabola. So again, as a becomes bigger, the parabola becomes narrower. I've already seen the effects in the changes of the value of a to the graph of quadratic function, which we call parabola. And I think you are now ready for a self-check. For our mastery, we